Hello, I'm going to show you one of the ways that I use to factor trinomials. And before I get to that method, I want to show you how I used this method to multiply two binomials together. So back when I taught Algebra 1, I would start with showing another way to multiply binomials in this method. And then that way when we got to factoring, they understood the whole concept. So you're probably used to multiplying these two out by the FOIL method, the first, the outside, the inside, the last. Then you combine the two middle terms, the two like terms, and create your trinomial. So these both are binomials because they're two terms each. A trinomial has three terms. So if we were to multiply this out, we would get a trinomial that's a quadratic. So I'm going to show you my other method. And here it is. So I make this little plus chart here, and then I take the first two terms and set them up side by side like that. And then I take the next two terms of the next binomial and set them up that way. And then it's still all just distributive property. It's just a different technique, a different format to do this. So what I do is I multiply the two x terms together, and that becomes x squared, and I put it at the top above those. Then I multiply the two constant terms, and that becomes the constant, and I put that up above. And then to get the two middle terms, this is like the outside and the inside combining together. So there's one of them, which would be negative 5x. The other one would be the 2 times x for 2x, and together 2x and negative 5x, you can combine them, and that would be negative 3x. So then that's your three terms for your trinomial. And we would say, okay, those two binomials, the product is equal to x squared minus 3x minus 10. So we put it all together that way. So that is how I showed a different way to FOIL. Again, no matter what method you do when you're multiplying polynomials, you're just using distributive property. So here's another example. If I multiplied, say, 2x minus 3 times 4x minus 3, here is how I would do it. The 2x minus 3 set up that way, the 4x minus 3 set up over there. And then we would go ahead and multiply the 2x times the 4x, and we'd get 8x squared there. The two constants, negative 3 times negative 3 is 9. And then multiply those two like terms, and you can see what's happening there, and you get those, negative 12x. So negative 12x, and this negative 6x is negative 18x. There's your middle term, and we would put that together and say, okay, there's the resulting trinomial. So that is one way that I showed how to multiply, because then I took that method and then we worked our way backwards to show how we can use that to factor. So here's an example coming up where I'm saying, okay, let's work backwards and factor the given trinomial. This is moving a little slow. I'm still getting used to this dossary here. So we're going to try to factor x squared plus 8x plus 12 using this method. So let's set up our little plus there. Remember, our x squared term went there, our middle term went in the bottom, and then our constant term went up onto the right. So it kind of looks like a triangle for right now, or some kind of face, or whatever you want to call it. So in the left two spots, the ones that are vertically transitioned or whatever, positioned over on the left side, that's where my two first terms would go. They have to multiply together to get me my x squared. So there's really only one choice for that. It's going to be x times x. And then for what goes on the right-hand side, remember, if I multiplied those vertically, they have to give me the constant of 12. And then they're going to have to add together to get the 8x. So there's different choices we have for 12, and I usually just list them off to the side. So 1 times 12, 2 times 6, or 3 times 4. And what I typically do is I work my way up from the bottom when I have a lot of choices. You might already see this and know which ones it's going to be, which factors, but if not, you can go ahead and try this. So if I put in a 3 and a 4, I get a 3x and a 4x. That's not going to give me an 8x. So I would cross that off my list, and then I would work my way up. So I would just erase my work there and then try the 2 and the 6. And 2 times x is 2x, and x times 6 is 6x. So together, those two do form the middle term of 8x together. So I know I found my correct factors. Now, what are the real factors there? It's not diagonal here. One of them is x plus 2, and the other one is x plus 6. So then I would come over and I would just state what that trinomial was in factored form. And then don't forget to check your factors, and then you can box in your answer. So let's try another example over here. I'm going to speed this one along here. Let's try factoring 2x squared minus x minus 28. Let me slow that down. Okay, so if we set this up, 2x squared up there on the left, the middle term down there in the bottom, and then the constant over there. So now we've got choice, well, the only choice for 2x squared is going to be our x times 2x. You're never going to have 2x squared times 1. It's just not how it's going to be. Each one of those on the left side has to have an x variable with it. And then on the right side, they're just going to be constants. So I know it's negative 28 there, and so that tells me that one of those constant factors or terms has to be a negative. One has to be negative, one has to be positive. I always figure out which one's going to be negative at the end. And I never put my negative over on the left side. For instance, I never have negative 2x or negative x over on the left. If my leading coefficient ever were a negative out in front, I would factor that out at the very beginning before I started factoring. And we'll do some of those examples in class. But for negative 28, I'm just going to consider positive 28 for right now. It's either going to be 1 times 28, 2 times 14, or 4 times 7. So again, if I'm working my way up and I put in a 4 and a 7 over there and tried it, when I get my two like terms together, I get 4x and 14x. That's not going to give me a negative 1x. So what if I turn that around, and I haven't used up all my choices for 4 and 7 yet because I have a 2x and an x now. They're not the same. So what if I erase the 4 and the 7 and put them in the different positions? Would that work? There I'd get 7x, and over there I'd get 8x. Could I possibly get a negative x there? Yes. How can I get negative 1 from a 7 and an 8 if the 8 were negative? And how did we get the negative 8? We got it over here where it would have been the 2x times a negative 4. That could have given us a negative 8. So you can see that one of our factors is going to be the 2x plus 7, and the other one's going to be x minus 4. And so we would put those together and check them before moving along, and then going to your next problem. So here's where I'm going to check it. Always check. Let's speed that up. So do a quick FOIL. Do a quick little first, outside, inside, last, and determine if you really did get it or not. So let's see, if we came back here and we're checking it out, is 2x times x, 2x squared? Yes. There we get, from our outside, we get negative 8x. For the inside, we got positive 7x. That does give us negative 1x, and positive 7 times negative 4 is negative 28. Check. It does work. Then we can box it in and know that we're good to go. So why don't you try factoring this next one, 4x squared minus 25x plus 36. And so go ahead and pause this as needed to try it. Start setting it up, and then go from there and see if you get what I get. Okay, so go ahead and pause and see if you can figure out what your factors will be, and then unpause it. And so do this on the side, on a scratch piece of paper or whatever, and try it yourself. Okay, so for 4x squared, our options were x times 4x or 2x times 2x. That's running a little slow. Let me speed that up. Okay, and for 36, we have 1 times 36, 2 times 18, 3 times 12, 4 times 9, or 6 times 6, so a lot more choices there. If I started with a 2x times a 2x, and then I tried going with my 6 times 6, I'm only going to get 12x and 12x, and that's only going to get me 24x or negative 24x, so that wouldn't work. And I'm going to have to... Okay, sorry for that interruption. Life happens here, right? Alright, where was I? Okay, 2x times 4, 8x. So that's not going to work. If we try 3 times 12, will that work? No, that's not going to work. And you know what? 2 times 18 and 1 times 36, they're not going to work either. So I would come over and I'd scratch off 2x times 2x and I'd try the x times 4x. And really, it doesn't matter which position I put those in. It really doesn't matter. What matters is how I line up the factors on the right side and whether or not they will together make something that can combine to get me negative 25x. And you can see that 6 times 6 didn't work. Let's see if the 4 times the 9 works. That would give us 36x and 4x. That's not going to work, but let's switch it around because it's 4x times x. So the position of the 4 and the 9, that would matter. So if we put the 9 there and the 4 there, can you see if that works? 16x and 9x. Could we possibly get a negative 25x? And by the way, hopefully you have already noticed this. If two like terms are going to add together to get negative 25x, but our constant terms are going to multiply to get positive, you should already see that it needs to be both negative constants over there. So a negative 9 and a negative 4. So that would work. And one of our factors would be 4x minus 9, and the other factor would be x minus 4. And by the way, it doesn't matter which factor you want to list first over there. You could have said x minus 4 times 4x minus 9. That doesn't matter because the factors themselves can be rearranged because of commutative property of multiplication. A times b is the same thing as b times a. However, these factors within themselves do need to be correct. It does need to be 4x minus 9, and it does need to be an x minus 4. Okay, so let's see what happens when we get something like x squared minus 49. Well, you might look at that and say, you know, there's no middle term. How do I do that? You can still use this method. It's just going to be a 0x. In the middle because your b term, your b is 0. Remember ax squared plus bx plus c equals y, that's your quadratic. Well, b is just 0 here. So your only two choices for x squared are going to be x times x, and then hopefully you can see over there it's either 1 times 49 or 7 times 7, and you should already have a clue that the factors have to be exactly the same, but one needs to be negative in order to get a 0 pair together for them to cancel out and have no middle term. So one of your factors needs to be positive, the other one needs to be negative, but they will look exactly the same. This is one of those special products over here of x plus 7 times x minus 7. That's because what you had was a difference of two squares. X squared minus 49, that's a difference of two perfect squares. The square root of x squared is x, the square root of 49 is 7, so one's x plus 7, the other one's x minus 7. And that's how you do those. But again, you can still use this method if you forgot. And then we have another special product over here, special quadratic, and it's really a perfect square trinomial. So I'm trying to go back and read and listen to what Sal Khan did on Khan Academy, but I don't want you to get lost into like all the A's and B's and C's and what do you do here and what do you do there. You could still use this method. You know, you don't need to memorize a bunch of stuff. Just sit there and go, okay, I could try this out. I've got x squared there. I've got a 12x in the middle. I've got 36x. So it's going to be x times x. My choices for 36 are 1 times 36, 2 times 18, 3 times 12, 4 times 9. Just list them all out there, and you work your way up the list. So if we start with 6 times 6, because that's at the bottom, we can get a 6x and a 6x. Hey, that works, doesn't it? 6x plus 6x is 12x. So we go, all right, there's our factors. Happens to be x plus 6 times another x plus 6. And because they're the exact same factor, oh my gosh, my neighbor is now doing yard work. I'm so sorry. This is what I get for trying to make a video at home. Let me pause this video again and go shut my window now. Okay, I shut the window. All right, so where was I? Because they're the exact same factor, you can list it once and just call it squared. So the quantity of x plus 6 squared. It's just one binomial being squared. that was a perfect square trinomial. It's one of those other special ones, but again, you don't have to memorize some special rules or anything. Just whatever method you're doing to factor, just keep on going. This is what I call the plus chart method. I used to call it a T-chart, but then that confused students and they thought I was talking about making an XY table for points on a graph. So it looks like a plus sign. I'm calling it the plus chart method, okay? If you liked your diamond method or Xbox method, Xbox 360, whatever you want to call it, that's fine too. It's just I'm trying to give you some other tools and strategies to use for factoring. So one other thing I want to do is, did you catch what I just showed on the screen there? I changed the x squared plus 12x to an x squared minus 12x. How would that affect your answer here if we had a negative 12x instead? So if you had a negative 12x, wouldn't those 6x's needed to be, wouldn't they need to be negative themselves? So they would both be a negative. And then would that still work? Would negative 6 times negative 6 equal positive 36? Yes, that would. So the only thing that would change now is your factors are x minus 6 instead of x plus 6. And that's how that would change, okay? So one of the things I wanted to talk about too was the fact that all of those previous examples I just showed you, they had no factor in common other than 1. One of the things you really should check for at the very beginning is a GCF. Check to see if there's a greatest common factor, because if there is, you should factor that out to the front at the very beginning. So before you even try to factor your trinomial, factor the GCF out in front, put it in front of a set of parentheses, and then what will be left over in the parentheses, that new trinomial, that's the only thing you have to go and try to make your chart, your plus chart, your Xbox, however you want to do it. That's what you should go and factor. It makes your factoring much, much easier if you remember to factor out a greatest common factor if there is one. Okay, well, I hope this helped. Forgive me for all the interruptions that happened while I was recording this and for my tongue tripping over itself here and there, but you get the gist of it. And if you need more help, just come into tutoring and we'll work then. All right? Bye for now.